This is a TAIG Micro Lathe 2, also known as a PEATOL in the UK, and this is a banana for scale. This thing is absolutely tiny and I'm really quite excited about it. So in today's video we're going to have a look and an overview at this brilliant little machine. The TAIG lathe, or PEATOL as it's known here in the UK, has really got quite a following out there. It's been out for a good few years and is massively popular. There's some fantastic websites, Carter Tools for one, which shows scores of people with lots of modifications, all kinds of funky things. And I bought this machine to do some CNC mods. I think in time what I'll probably do is put a ball screw through here, but I've seen some ingenious CNC mods which basically have a clamp-on 3D printed interface which just puts a NEMA 17 stepper motor on this little slide. So it competes in the same market as Unimat and Micro lathes and basically is a really simple bit of kit, but by all accounts very accurate. So if we take a bit of a tour, we'll start off with the bed. The bed, ingeniously enough, is a aluminium extrusion, and all the real machinists out there will be thinking aluminium, that is not a great choice for a machine bed. Everything's generally cast iron, but of course this is aimed at the hobbyist market, but it's trying to be fairly accurate, reduce vibration and whatnot. So what they've done actually is in the extrusion they've filled it with concrete and capped it off, and you can still see a bit of this sort of concrete or some kind of epoxy residue around where it's been filled, which is really quite clever. And the thing is, I haven't weighed it, but it's pretty weighty actually. So we've got this aluminium extrusion, obviously aluminium very soft. So what they've done is they've put on a piece of ground steel, and I think part of the actual installation process is these are lapped in with the various slides which come with the machine. Now, it's a modular machine. You can upgrade it as you go. PEATOL, I think it's peatol.co.uk in the UK, sell various accessories, and they're also available through TAIG. There's a fantastic channel run by John Headstock. I think he's possibly the founder of TAIG, or certainly has something to do with the business, and he creates all kinds of accessories. So there's a really vibrant community and aftermarket for this lathe. So that's the bed. On the base model, you'll notice we've got a Z-axis and an X-axis. There is no compound slide, however, which can be purchased and upgraded, and is something that I'll be planning to do, as the real basic CNC upgrade uses the compound slide to drive the Z rather than the main Z. Most of the work I plan on doing this lathe will probably be within, I would say, probably a 40mm envelope. So having a drive on the Z compound will be fine for me. So let's start at the headstock end. The headstock is basically a two-piece extrusion. In there we've got bearing either end. I believe there's some kind of spacer, and we've got a pulley at this side, circlip on this side, and we've got an arbor onto which various work holding devices can be attached. In this case we've got a little 3-jaw chuck with soft jaws. So bear in mind this thing can spin up to 7,000 RPM allegedly, which sounds perhaps about right if you're going to be turning soft materials that are very small diameter, and this looks like aluminium soft jaws actually. There is no, it's a self-centering 3-jaw chuck. There is no key, so it's just a pair of Tommy bars which operate the self-centering chuck, and there's a bit of a scroll inside. So I believe you can put an ER16 collet system on there. There's also, I don't remember the name of it, but there is another collet system available. I think it's just 3/16 collets. And with this lathe I also on the eBay listing got a 4-jaw chuck, and it's a 4-jaw independent. let's have a look at the back side of it, and you'll see the kind of it looks completely unused, but from the spindle nose there's a screw thread on there, and that looks like a, oh no, it has been used, look, although it's in pretty good condition. So that's the headstock, and it's driven by means of a belt and pulley onto a motor. Now typically I believe it's what's known as a 1/4 horsepower marathon motor. This particular model looks pretty similar. It's by GE, General Electric, and basically just provides drive via a stepped pulley. It comes with a little belt, a tooth belt, weirdly enough, even though there's no teeth. There's a bit of a V-belt sort of arrangement there, and by adjusting the velocity ratio between the two pulleys, this is on a mounting system. I think basically this thing will hinge at the back, which will provide the belt tension. You can adjust the speed. Now, hopefully I'm going to set this up as a screw cutting lathe, a little tiny experiment before I branch in something bigger. So I suspect I'll change this out for some kind of DC motor with a little encoder on the end eventually, but I plan to do lots of manual turning with this before that point. So on the headstock is a little depth stop, so you can set your stops. That's a nice little simple system, which is lovely. Let's have a look on the back side of the lathe. Just another view of the headstock and extrusion. You'll see these little sort of carriage locks throughout the machine. Spin it round. So from the headstock we've got the carriage. Now there's no, on this model I believe they have recently introduced a model which has a lead screw running across and a power feed. This does not, and it actually has, if I zoom in on that, a rack and pinion type drive, which is you know, there's not a huge amount of backlash in there, so that's very there's no movement really, and any amount of movement does give a traverse in the Z, so that's clearly quite an effective system. If we look at this main saddle, then, and for this I will flip the lathe over. It looks like an aluminium casting. There's a bit of an eccentric bushing here which will provide a means of engaging this pinion with the rack, and there's obviously a bit of a plastic chip guard here to prevent the rack getting covered, but it's really quite a simple machine. Cast, grub screws, and as you turn that provides the Z movement. The X movement is by means of a lead screw. So I'll flip it over and we'll have another look at this. So as you turn the carriage, obviously you generate movement. Now this has been a well-used lathe and there is a good amount of backlash. I mean, I'm a UK based, God dare I say it, millennial. So I've been brought up with SI units, millimeters. So these are 1/1000, so basically just a bit more than 1/4 mil. So we're looking at probably about 1/2 mil backlash there before you generate your movement. However, I'm not overly worried, as I think I've got a solution to that particular problem, which I'll come on to. Right, finally onto the tailstock. Another locking set screw here into an aluminium extrusion. The tailstock itself can be offset on this dovetail, which will provide a basic means of taper without the compound slide. Now, in my eBay listing, I didn't actually receive a a centre of any kind, but that'll be easily enough picked up. It's got this Jacob's chuck, and look at this for a nice mechanism. It would probably take a bit of ingenuity to set the stops and whatnot, but there's various clever solutions where people have mounted dial test indicators or slightly butchered, cheap digital verniers so that all of the moving components will give a digital readout. Because I've been spoilt in my machine use, and I've always had digital readouts, DROs, on the machines. I've got a few videos on that on the channel if you're interested. Tool holding, simple enough. You can get a bolt-on aftermarket quick change tool post. This has just got a simple little post with shim stock to get the tool height. Quite how we was doing this, I guess maybe off a perhaps a centre drill in the back to guess it, but the way the tools are ground in the box, it doesn't particularly look like the chap knew what he was doing really, but the lathe is in good nick, so perhaps I'm wrong there. A couple of little accessories that I'd like to show. This is a milling slide. So the idea is you would take off the 3-jaw, put a milling cutter in there, remove the tool post, and then this would be mounted on the cross slide. Stick it on here, and it provides a rather sort of rudimentary milling system, so you can make X and Z and Y movements in lathe terminology by moving this up and down. Now this, pretty unsurprisingly, was obviously bought as an experiment. It's virtually unused. You can see the gib on there, there's a lead screw and a lead screw nut in there. I'm looking forward to disassembling this thing, because what I plan to do is butcher this, put the lead screw and nut and any of the anti-backlash stuff in this, because it looks to me to be exactly the same setup, just with a different sort of base on it. And I'll swap it over because I'm not too worried about backlash in this. If I ever do a little bit of sort of experimental milling, then I'll just deal with the backlash at the time. But if I'm doing a CNC conversion, then that's a bit of a bummer, because I believe Mach 3 has some kind of backlash compensation, but there's nothing like sorting it mechanically. So some interesting stuff there. There's a few other bits. I've got various tools. I'm probably going to use insert tooling wherever possible, but one thing I am quite excited about is having a gang tooling set up, almost in the same way of a capstan lathe, where maybe I'll have a parting off tool on the back and some kind of turning tool here, and maybe a drill on, so I can do a number of operations off one tool post. Maybe mount a parting off tool or a cut off tool upside down in that one. So that is a very, very quick overview of this lovely little lathe. It's a TAIG Micro Lathe 2, currently unmounted and on my kitchen workbench, but something I'm really excited about using in the coming weeks. So stay tuned, do subscribe if you like TAIG videos, if you've got one yourself, you're thinking of getting one, and I look forward to your questions and comments, and if you have any tips for me, let me know in the comments below. Bye for now.